In this video, we will talk about Minimax algorithm with Python. What is Minimax algorithm? This is a recursive backtracking algorithm that is used in decision making and game theory to find the optimal move for a player. So recursive here is a function that solves a problem by calling itself, while the backtracking and recursive is almost the same thing. Backtracking solves a problem using recursive function. And in this algorithm, mostly used in two-player games like chess, Tic-Tac-Toe, Go, and etc. The two players of the games are maximizer and minimizer. Then the maximize player will select the maximize value, and the minimizer player will select the minimize value. Both players will strive to find the optimum value for themselves, while preventing each other to get it at the same time. So this is the algorithm is all about. The decisions are made by considering other players' move. The maximize worst case here is negative infinity, while the minimize worst case is positive infinity. And this is obviously because the maximize will select the highest value, so his worst case is of course negative infinity. And then, how does it work? This is a decision tree that I made. Let's assume that the lowest level here is the endgame result. The 1 here is the maximize win. The -1 here is the minimize win, and the 0-1 here is draw. As the maximize player, of course, you want to win, and you will choose 1 here. So the highest value here is 1, the highest value here is 0, and the highest value here is 1, and leading you to victory. But unfortunately, the minimize players here will hinder you from doing that. So he will choose the 0 because 0 is lower than 1, and forcing you to choose 0, and the result is draw. What about the right subtree? Alright. The highest value here is 1, and the value here is -1. Because both of them are -1, the maximize players have no other choice than choosing -1. And the minimize here, of course, will choose -1. And the maximize here will still keep 0 value here because the 0 here is higher than -1, and the result is draw. And then, how does it work in Tic-Tac-Toe context? The decision tree used in Tic-Tac-Toe is much bigger than the decision tree in the previous slide. The first level here contains 9 nodes, which means there are 9 scenarios of the first move, where the maximize player choose the top left here, the top here, the top right here, until he choose the bottom right here. In each of the 9 nodes, there are 8 nodes representing the scenario of the second move of the minimize player. So in this node, there are 8 nodes. This is also 8 nodes until the end here, 8 nodes. And this tree is much complex than the previous slide, but fortunately, this tree is less complex than the decision tree used in the games like chess. Alright, let's jump to the code. Here is the code that I have set for the Tic-Tac-Toe game. You can download it through the link in the description. You don't have to worry because I have written the purpose of some of this function here. So you can pause this video and read it first. Let me explain some of the constant. In line 1, format import infinity for the initial value for the players. And in the second here, import system and os because I need some of the system help. And the human here is assigned as 1 because this is a maximize player and this is a minimize player. The board here is written as the nested loop, or you can call it a matrix. And the message here is just an opening message before the game starts. Alright, this is the evaluate function. This function will perform heuristic evaluation from board. The heuristic here allows the computer to discover the solution of some problems by itself. So the function here will score the board state every time. Let me write here. If the human player is win, the score is 1. As if the computer players win, the score is -1. And if none of them win, the score is 0, which means this is true. And return the score here. Alright, the next function is empty cells. This will extract the remainder of the board. We will create the empty list here to store the empty cells index. To search the empty cell index, we will iterate through the row in enumerate state here. This will iterate through all this row here. And for every row, we will iterate through all this value here. Here, all of here. And then, if the value of the cells is equal to 0, which means empty, we will store it in the empty list here, and then return the cell. I use enumerate here because I can iterate through index and item. This is the index, ing, and this is the item, row and cell. And the next is wins. This function contains all the winning conditions. Players are win for sure if their symbols, cross or circle, are placed in 3 consecutive lines. For example, 3 in a row, which means in the index 0, 0 here, 0, 1 here, and 0, 2 here. And the same goes apply for the remainder of these 2. Okay. To determine the winner, we use if the player in the win state return true. This means the maximize or minimize win. Else we will return false, which means no result. No results or row. And the next function is pretty straightforward. This will check the game over condition. So we will just return wins if the player humans or the computer players win. And this will return false if no one wins, and else this will return true. Okay. The next function is clean function. This will clear system terminal. So before we clean the system terminal, we need to know what is our operating system name using system standard library and use platform. And this will return a string. So we can use the method lower here. So this string will be lowercase. And then if our operating system is Windows in OS name, we will use the command cls here. Else for the Linux operating system, we call clear. All right. Here comes our main function, Minimax function. This is a Minimax implementation for computer moves. It recursively traverses the tree to search the best possible moves to hinder other players' winning move. This function will return the list of best row, best column, and best score. So first we will initialize our player's value. If the player here is human, the initial value here is -1 and -1. This is a dummy value. And the worst case here is -infinity. If you remember my presentation slide back then. And else, if the player is computer, the initial value here is -1 and -1, and the worst case here is +infinity. So in every recursion function, there are 3 rules that we need to fulfill. The first one here is there is a base case. So our base case here is if the depth is equal to 0 or the game is over, we will evaluate the board score and return the null value and the score here. And now to create the decision tree, we need to iterate through all the valid moves here. So every valid move in the empty cells, we extract the row and column index. And then we commit the move of this player. After we commit the move, we calculate the score of this move using Minimax function. By writing the statement here, we already accomplished the second and the third rule of the recursive function. The second rule here is the function must going towards the base case. Our base case here is when the depth is equal to 0. We accomplish it by decrementing the depth by -1, so it can reach the 0 value here. And the third rule is the function must call itself, which we accomplish by calling the Minimax function inside the Minimax function here. We write the negative player here, so we can switch between the player. If the player is human, we can switch to computer, and when the player is computer, we can switch to human, and so on. If you're still confused about what's going on, this is just a move scenario in the Tic-Tac-Toe. So for each move here, we will evaluate the score of the move. So the current player will choose the best move from all of these valid moves. So when the move in the top right is score 0, but the move in the center is scored 1, of course the maximized player will choose the center because the score is higher than the previous move. Okay. So after we calculate the current move value here, we undo the current move by assign it with 0 value here, because before we use the player value here, and we need to keep the row and column index from X and Y to replace the -1 value here, because we already got the score value here from this function. And then if the player here is computer, and if the score here in the index 2, which means in here score here is less than the base 2 here, we will change the base variable here with the current score value here. Okay, the same goes apply with the human player. If the score here is larger than the initial value, we switch the base score with the current score here, and we return the base score. Okay, and the next function is human turn function. This function is pretty intuitive. So I have mapped all the available moves here from number 1 until 9. So the number 1 here represent the top left of the matrix, and the number 9 here represent the bottom right of the matrix. Okay, so before we begin our move, we need to set up some important variable. So first, we need to identify how many available moves are left using this empty cell function here, state, and we create a variable with the value true, and we need to inform the user that this is the human turn. Okay, after this variable is set up, we begin our turn using this while loop here. While is turn, whenever is turn is true, we will using the try and except here to catch some error. Alright, before begin the move, we need to questioning the human player what the move is using the input built-in. Okay, the input please enter number from 9 until from 1 until 9. Okay, so if you enter digit in the terminal system, it will be identified as the string, and we need to convert it into integer. Okay, and using condition here, if the moves get move. Okay. If our move is available, we store the row and column index in the variable x and y, and we commit the player move in the specific index equal to human, and we can end our turn here. His turn is false. Okay. If the player enters the wrong number or the invalid move, we can print bad move here. Bad move. Please try again. Okay. So there is a circumstance where, for example, he entered the string S here. So this will be considered as the value error. So we can catch the error here. Accept the value error. We print. Please enter digits. Please enter digits from 1 until 9. Okay. And after we end our turn, we use else here. So this is a while else loop. So whenever the while loop is end successfully, we will be redirected into this else statement. So we can clean the terminal system and print render the board. The render function here will just print our current board condition. So I will explain it later. The next function here is also pretty intuitive. The function AI turn. This will handle the computer move. So before that, we need to identify how many the moves are available using this variable here and the length of empty cell here. And after we identify all the available moves, we need to find out what the optimal moves amongst all the available moves using this statement, row, column, and scores in Minimax function here, state, the depth here, and the computer players here. So after the computer has identified the row and column index, we need to commit this move to computer. Tell the user that this is the AI turn. And finally, we need to render the current board here. Okay. The next function is render function. This will render the board state to standard out. Our current matrix here is a numeric value. So we need to replace it with our desired representation, which means the cross will be human player and circle will be computer player. To do this, we need to create this dictionary. 0 will be empty blank space, human player will be cross, and computer player will be circle. After we made this dictionary, we need to apply this rule to our Tic-Tac-Toe board. So the function will be list map. The rule here, lambda x, list comprehension here, legend y, for y in x, and we enter the iterable here, which means the board itself state. So the x in here is our matrix row, which means this is row 1, row 2, and row 3. And the y here is each of these row value, 0 here, 0 here, and 0 here. After we apply this rule to our matrix, okay, I forgot to close this bracket. We need to convert it to string representation. This will be result is equal to triple curly bracket here. Separate it with line break here, line break 1, line break 2, and line break 3. And its curly bracket here will contain every row in our new representation here. So we need to return the result. Okay, this is the last function, the main function that will running at start. This function will handle our game flow in Tic-Tac-Toe. So at the beginning of the game, we need to print the message that I have pre-written here, welcoming the player, and we questioning the player confirmation if he want to continue or not. Okay, so to answer that, we create this boolean variable. The start will false while the game is not started. While not start, we need the player confirmation, which is input. If the player is ready, when he write yes or y here, so the lower method here will ignore or will be case insensitive. Okay, if the player is ready, we can start the game with star will be true, and else if the player didn't want to continue, call the system exit here, and else when the player enter the wrong value, we inform him to enter either y or n. Okay. So after this while loop is end successfully, we write else here. We clean the terminal and inform the player if the battle is settled, and show the player render the current board here, and we need to separate it with line break using \n here, and using this argument, and is equal to line break here. Okay, when the game is start, while no one is win, we board human and not wins board and computer. Okay. While no one is win here, the first turn will human turn and the second turn is AI turn. This function will run in cycle. The human turn first and AI turn second, and human turn then and AI turn later. So this function will break if human or computer player is win, but if the tic-tac-toe board is full, which means there is no remaining move, we need to break the function. We need to break the loop. So we write if the length of available move is equal to 0, we break the loop here. Break. Okay, after we break the loop, we need to evaluate or identify the end result of the game. If the human player win, we can print here you win, you are insane. Else if computer player is win, you can print I win. Now I will take over the world. And if the game is draw, we can type it's a tie. No one wins. Okay. Now we are ready to play our game using if main statement here. We call our main function and start the script. Okay, this will take a little longer. Okay, welcome to Unbeatable Tic-Tac-Toe. Our AI can foresee your moves ahead. Are you sure to continue? Of course. Please enter number from 1 until 9. I will choose 5 here, so I can place the center. Okay. Okay, the AI here is on the top left, so I will move in here to the AI is know what I'm thinking, so I can move here 3, and the AI is pretty smart, but I won't lose, so I will choose 9 to hinder the AI win. Okay. Okay, I forget if the AI can win here. So that's it for the tutorial. I'm sorry for the bad English here because this is my first time. Okay, thank you for watching. Enjoy.